Let's solve a system of equations using matrices and a online calculator. We are going to use Desmos matrix calculator. Desmos matrix calculator right here. Click on the link, and then we are going to type in our matrices. This video is going to be based on another video called System of Equations number 7. In that video, we had a word problem with coins, and we actually set the problem up and set up matrices. We just needed technology to actually solve that problem. So if you want to see the problem, just go ahead and watch the System of Equations number 7 and then come back and see what we are doing here. Now we set up actually two matrices. One matrix was a matrix of coefficients. So to make a matrix in Desmos, we simply just click New Matrix, and it defaults to 2 by 2 matrix. But we actually want to make 3 by 3 matrix, so we need to just increase number of rows and increase number of columns. Now this matrix is going to be matrix of coefficients, which is coefficients in front of D for dimes, N for nickels, and P for pennies. Or it could be just our X, Y, and Z if we have a different set of variables. So the coefficients were actually 1, hit tab to go to another box, 1 again, tab, 1 again, tab again. Then second row was actually values of each coin. So first we had dimes, so it's 0.1. Hit tab again. Then it was nickels, so 0.05. And then the last column was actually pennies, so 0.01. Hit tab again. And then the last row, we had a negative 1, then 2, then no pennies, so it was 0. And then we just now hit enter here, and we have our first matrix. Now this calculator kind of works similar to TI-84, because in that calculator we also need to first make matrices and then do operations with them. In our video matrices number 1, we used TI-Inspire calculator, and in that calculator we can actually just make matrices as we go and do operations with them all at the same time. But anyways, it doesn't matter, it works pretty nicely. So this is our coefficient matrix. Now we need to make another matrix. Let's call it a matrix B. That's not good. We will call it matrix B. Well, let's first make the matrix like that. Okay, so now this is matrix B, and again defaults to 2 by 2. But our matrix is actually 3 by 3, 3 by 1. Oops. 3 by 1. This is our coefficients matrix, which is actually just the numbers on the right-hand side of the equal signs of our three equations. And the numbers happen to be 48. That's how many coins we had. Hit tab. Then 3.56, which is what was the value of those coins in dollars. And then we had 0 because we moved everything to the left-hand side. So again, this is our constants matrix, which are just numbers on the right-hand side of our problem in Systems of Equations number 7 video. We hit enter again. Now we have two matrices. What we said in that video of system of equations number 7 that now to calculate x, y, and z, actually to calculate d, n, and p in this case, what we need to do is make the inverse of matrix A, which we just do by clicking A to -1 here. Now this is the inverse, but we don't really need to know what the inverse is. What we need to do is multiply that inverse by the matrix of coefficients, which is B in our case. And then once we do that, we get another matrix, or actually a vector, with numbers 28, 14, and 6 in it. Since our variables are D, N, and P, dimes, nickels, and pennies, then our answers are in the same order, D, N, and P. So that means we had 28 dimes, 14 nickels, and 6 pennies. So those are our solutions, our x, y, and z, if you want to call them that. That will be it for this video. I hope you like it. If you do, please click like, click subscribe, and don't forget to smile.